We are going to work out a question which actually uses the expected value criterion in making decisions under uncertainty. So you might have practiced some of the questions in the topic of decision making under uncertainty, and you might have applied other techniques as well. In this session, we are going to look at use of expected value criterion. So the question in front of us is, Smart Incorporated can choose from 5 mutually exclusive projects. The project will each last for 1 year only, and their net cash inflows will be determined by the prevailing market conditions. The forecast net cash inflows and their associated probabilities are shown below. So we are given some market conditions. A number of cases you may consider the weather conditions, but we are given the market conditions which can turn out to be poor or good or excellent. And the probability of the market condition being poor is given as 0.2 or 20%. The market condition being good is 0.5 or 50%, and the market condition being excellent is 0.3 or 30%. Then we are also given in the table below forecast net cash inflows in thousands of dollars about the 5 projects under consideration which are mutually exclusive. Project L, M, N, O, and P, and their cash flows are given right in front. Requirement is based on the criterion of expected value of the net cash inflows, which project should be undertaken. So before actually we work out this exercise, you need to make sure that you understand the idea of expected value. So what is expected value method? Expected value simply represents a weighted average value of all outcomes. And when there are different projects like L, M, N, etc., we calculate expected value of each project, or to be a bit more wider idea or understanding of each decision, that should we choose L or should we choose M. So for each decision under consideration, we calculate expected value for. And expected value is calculated as expected value equals to the sum of Px. So you know this sign, sum of or sigma, Px, whereas P represents the probability of each decision or outcome, and X represents the value of each outcome. Okay, so expected value equals to sum of Px, which is the probability times by the monetary value of each outcome. And once we have calculated the expected value in relationship to all decisions under considerations, we choose the highest expected value as our decision point. So whichever project, whichever decision results in the highest expected value, being a risk neutral decision maker, we choose that highest expected value and make the decision. Now let's have a look at how will we arrive at the decision under consideration. So here is the payoff table which was given to us. Net cash flows were given for each project, and we were also given the probabilities of each market condition. So all I need to do is I will pick up a calculator, and all I'm going to do would be multiply P by X. So for example, if you can focus here, first of all, I'm looking at the poor market condition. So 0.2, I'm going to multiply by project L outcomes, which is 500. Okay, so just one or two numbers I need to show you, rest you can easily work out yourself. 0.2 times by 500, I suppose everybody says 100. Then 0.5 multiplied by 470. So I think everybody is telling me it comes to 235. And then 0.3 times by 550. I mean, you don't need to rush. You can work out. Look, 550 multiplied by 0.3, and hey presto, we end up with the 165 here. Okay, so first we multiplied probability factors by the values of the outcome. And now we are going to do the sum of Px, which in simply is 100 plus 235 plus 165. So again, as my calculator is here, 165 plus 235 plus 100, and that comes to 500 in total. So 500 is the total figure, sum of Px. Now let's have a look at the project M. Okay, project M is 400 times by 0.2, which gives me 80. Then 0.5 into 550, okay, which is 275, and then 0.3 into 570, here you go, 171. So 171 plus 275 plus we have 80. If I add from there, we get 526. 526. Okay, likewise I'm going to work out for project N as well. So 0.2 into 450, 225, then 0.5 into 400, which is 200, and 0.3 into 475, 475 times by 0.3, which is 142.5, and I will add 200 and 225. And comes to 567.5. Okay, so you can work out for project O and project P as well. Okay, we have time, we can work out quickly here. 0.2 into 360 times by 0.2, which is 72. Then 0.5 into 400, which is 200, and then 0.3 into 420, so 420 times by 0.3, which is 126. So 126 plus 200, which is 326, 326 plus 72, 326 plus 72, 398. Right, like this I can work out for the next as well. But all I had to do was I would simply look at their expected values, and so far the highest expected value is coming from project N. So if there was no project P, I would have chosen project N, but because you have to do some practice as well, so please try the same method for project P, and then after see whichever project is generating the high